Okay, let me do my share screen. Okay. Okay. Okay, my shared topics. Do you see them? Yes, Mercedes, you're on mute.
Yes, I can see them.
Okay, Alva, can you see the topics?
Yes, Miss Barbara.
Okay, so this is what we will be doing today. We'll go to the homework. It was on exponents, radicals, and scientific notation. And we may have time to introduce you to probability. If not, we'll do it on Thursday. Okay, so let's look at the homework. Let me go to a new share and look at the homework. Okay. Alva, what does number 1 say? Read number 1.
You said exponent and radical scientific.
Yeah,
No.
just read number 1.
Oh,
Problem
number
number
one.
1.
You say which number is the exponent?
Now, which one did you say? You sent me some answers.
Yes, I think I picked 3.
You,
A.
okay, A, B, C. You said
A.
okay, you said A. Well, you said 3. Okay. And that is correct. Let's see.
Okay.
Mercedes, you sent me. Mercedes, you said B.
Yeah.
Why?
Because of the 8. Thinking that
You said B.
yeah, I did.
What is okay? 2 is the base,
Okay.
right? 3 is the exponent. And this is what it is equal to. Because this is when you say 2 times 2 times 2. That translates, right? 2 to the 3rd power means multiply 2 by itself 3 times.
Okay. I got it wrong. I didn't understand. Because that's what I'm thinking, that I said choose 4, 4, choose 8. That's why I choose 2, but I forgot to think that it's 3.
Well, the structure of an exponent when you give a power, you have a base and then you have the power. The power is the exponent. This says 2 raised to the 3rd power. That means 2 multiplied it by itself 3 times. So that translates to 2 times 2 times 2. So 3 is the exponent, 2 is the base. Remember, I gave you some properties of exponents and I told you the base.
Baba, remember, just slip me.
Okay.
Right.
All right. Okay. So just remember the structure of when you're given an exponent, a power. Exponent is the power. And the number that you use to raise to the power is the base. Okay. 2 is the base, 3 is the power. Okay. Any questions on that one? So what would be the answer, Mercedes?
A.
A. Okay. Answer A. Okay, Alva, you have that one correct. Alva, number 2. Read number 2, Alva.
Okay, let me pull it up, Miss Bond. Yeah. It says
Just say it in words.
No, I'm looking on the reading. I'm not getting it to you.
You're not seeing number 2 right here?
I am seeing it, but is the reading?
No, I want you to read what it says in words. I have numbers, okay. I have powers. I want you to read it in words.
Okay, it says 12 to the 5th power.
Right.
Divided by 12 to the 2nd power.
Excellent. Excellent, Alma. That's what I want you to say. You know, this is a division. 12
Yes.
to the 5th power divided by 12 to the 2nd. And what's the rule for division of exponents, Alba?
You multiply the,
No, we're talking division now. So
you
when
say
you divide, what do you do to the powers?
you had,
No, you add when you multiply. Remember
you
the
said,
properties I gave you? When
oh,
you're doing division, you subtract.
yes,
The
yes.
rule is you subtract, right?
I got that one wrong. Yeah.
Okay, but remember your rules. You have to refer back. I gave you a list of the rules. You remember the properties we've been going through?
Yes, ma'am.
Right. So when you're doing division,
You divide,
you
you
subtract.
subtract. Yes.
Subtract the exponents, right?
Okay, so I have that one wrong. Yeah. Because
Okay, so you subtract the exponent of your denominator from the exponent of your numerator. So this would become what? 12 to what power? What will I
to the
subtract,
third,
Alba?
to the third power.
Yeah, to the 3rd. That's right. Excellent. Because it's 5 minus 2.
Two.
And
Yes.
that's equal to 12 to the 3rd, right?
Third power. Yes.
Equal 12 to the 3rd power. So let's just put that there.
But didn't I sense C,
Let's see, what did you say?
or maybe
For
it's D?
no, number 2, you said C. Wait, just yes, you and Mercedes said C. That's correct. So you had
Yes.
that one correct.
Yes,
All
ma'am.
right. So what would be the answer?
C.
C. So let's put here. I'll just put it here. Here's the C. And put here answer C. So now you understand division. You know the division rules of exponents. Subtract the exponent of your denominator from the exponent of your numerator. Okay, so
Yes.
let's go to number 3. Mercedes, read number 3.
Okay, number 3. Can you hear me? Okay.
Yes, I can hear you.
Number 3 says, what is the value of X? So the below equality is true.
Okay, now you didn't do that one. And Alva, you said A. Do you know why you said A?
What I did, I was doing the denominator. No, the numerator.
Now, no, let me ask you, this is a multiplication, right? So
Yes.
what's the rules for multiplication of exponents? Alva, you remember? You said it earlier. What do you
Yeah.
do? What do you do? Go ahead, Alva, you said it.
Add up the denominator.
Add up the powers. So multiplication, you
Yeah.
add the exponents.
Yes. Okay, so
Okay, so that means you've got to add the 5 and you've got to add the 19, right?
that's 24.
So that, what is that?
24.
Okay, so this would be, let me just write this. This will be 1 over 5. And let me just put, since it's adding, that would be to the 5th power plus 19, right? And what did you say that was, Alba?
Equal 24.
Okay, so the power now will be, let me just repeat what we have here, 1/5 to the 24th. So let's put the 24th power here. Okay, now Alba, if that's 1/5 to the 24th, now Mercedes, you know what X is, right?
I'm not sure.
What would you say it is?
24.
No, what is X?
X would be 1/5.
Oh, let's put this here. 1/5. Let me just copy that here. To the 3x exponent. So let's just put that there. All right. And let me put this here. Equal 1/5 to the 24th. Alva, you know the answer? Let me just copy that there and then you can probably see it. Okay, 1/5 to the 24th. So let's just copy that there. Now what we are saying 3x is equal to 24. Alva, so what is x?
Okay, X would be 8.
That's it.
Yeah.
Yeah,
X would be 8. Very
Just
good,
yeah,
Alva. See how
got
you
it.
got it? X
yeah,
would be 24
yes.
divided by 3, and that's equal to 8. Mercedes, you see it?
Yes,
3,
yes.
24. Yeah.
As as soon as you write it out, I said, oh my God, it's divided by 3.
Yes. And then when Alva said 24, I said, she knows you add the 5 and the 19th power and get 24. Now 3x is 24. So what is x?
Yes.
Got to be 8. That's the only number that will multiply by 3, right?
Yes, mom.
8
Yes.
times 3 gives 24.
Yes.
Questions on number 3?
No, miss. I think
Mercedes, why did you put a question mark there? You didn't write it out?
because I was doubtful, so I'll just leave it.
Why did no? You didn't write out? Well, you know the rules for multiplication is you add the exponents. You didn't write out the 5 plus the 19.
No, miss. I said I don't want to get it wrong, so I leave it.
Oh no, you can't do that if you know the rules. And just like Alva just said, 24. Add the exponents. Then you ask yourself, okay, if that power is 24 and that power is 3x, what does x have to be 24? Something multiplied by 3 gives me 24. That something is 8.
Yes.
Got it?
Yes, thank you.
Now, you should be able to do this next time, right? But always write it out according to your rules. Like Alva, you said 24. 5 plus 19, 24. Now, that 1/5, 1/5 to the 24th is equal to this 1/5 to the 3x.
Okay.
So ask yourself, see the math. 3 times what number gives 24? It's not a 1. 3 times 1 is 3. Not a 2. 3 times 2 is 6. Not a 4. 3 times 4 is 12. But it is an 8. 3 times 8 is 24. Got it? So what's your answer, Alva?
8.
Answer D.
Yes, D.
Yeah, letter D. And that's 8. Okay. Questions on number 3. You think
No,
you'll be able to solve one like that again, right?
I believe so.
Okay. So you'll see
I have
that kind of problem again.
here now, Miss Barbara, the phone. Oh my goodness.
What is it, Alva?
No, I say I'm having a problem because some of the math. Oh, you didn't go on to 4 yet.
I didn't go to 4 yet.
Oh, okay.
So, Alva, you understand number 3 now?
Yes, Miss Barbara.
Okay. All right. No, I can understand you have some problems with it. Exponents are not always the easiest thing to understand,
No,
but you
no,
have to practice. You got to practice.
it's the phone, Miss Barbara, the phone.
I'm sorry.
No, I said I have a problem with the phone, but I forgot you did not put up the 4th one as well.
Oh, yeah. I didn't get to the 4th one. I just want to make sure. Any questions on number 3?
Oh, thank you.
Okay, let's go to number 4. Okay, number 4. Okay, Mercedes, read number 4.
Simplify 10x to the What's that? Positive 3 power.
To the power.
Okay, 10x to the -3 power. Isn't that a negative? Mercedes, you say negative?
Oh, yes, ma'am.
Okay. Now, I told you something about negative exponents. Alva, you remember what I said?
You say negative, you go to the. Mhm. Well, I think the negative is on the left.
No, I gave you a rule about negative exponents. And what did I say?
Oh, okay. So you're,
Reciprocal of the positive, right?
yes.
Remember? So that means you flip it. Okay, let me just put it here. X to the -3 is reciprocal. That it means you flip it. This is over 1. Let's just do it like this. Okay, this is over 1. Okay. 1 is the default. Now that's equal to, and if I flip it, then the 1 will be in the numerator, right?
Yeah.
Correct?
Yes, Miss Barbara.
Okay, so this would be equal. Okay. And this will be what? If I flip it, Alba, what would it be?
It would be, if you flip it, it would be equal to,
So the 1 would be in the numerator, right? So that would be a 1.
yes,
And what would be in the denominator?
the 3 or the X.
No, you can't separate it. It'll be x to the +3.
Yes.
So let's just copy that and put it here. Okay. But it won't be a negative. It will be a plus, because remember we changed the sign. Let me flip it. Okay. So this will be x to the +3. So let me just take the underline out here. Okay. So that's the rule now. Whenever you have a negative exponent, you flip it and it becomes the positive exponent. So you're just really turning it upside down, right?
Yes.
So, any questions on that rule now?
What did you do with the 10, miss?
Mercedes, what was your question?
What you did with the 10?
No, I haven't gotten to the 10 yet. I just want to make sure you understand
Okay.
the
Okay.
risk, when you're given a negative exponent. That's why I took it separate.
I thought you're finished with it.
No, I'm not finished. I just want to make sure you know when you have a negative exponent, you put the numerator, you take the denominator, put it in the numerator, and take the numerator, put it in the denominator, and change the sign. So x to the -3 over 1 is 1. You flip it, 1 over x to the +3. So you flip and change signs. Got it?
So you're saying I see 10x to the -3. Okay, so I don't understand how you get the 1. Is the x, this is the 1?
No. Whenever I'm not doing the 10 yet. We haven't solved the problem.
I
Okay.
know.
I just want to make sure you understand when you have a negative exponent, how you express it as the reciprocal of the positive exponent.
Yes, you say you flip it.
Okay. Now, to
Yeah.
solve this problem, well, we've
The
taken care of this, right? Let's see, 10. Let me just copy this and put it here. Okay. Now I know my 10 will stay the same, right? But my x to the -3 becomes a plus. So I just take my 10 and put it over my x to the +3 right here. And that's the answer.
You put it over the X, so
Put it
it's
over. Well, I'm taking out that numerator x, okay? Because this comes out right here. because that becomes 1 over x to the third. And 1 over x to the third is 1 over x to the third.
Okay, so how you get the 1? You say how much time 1 make 10?
No,
Okay,
whenever you have a variable or a number
yes,
and you don't have anything under it, it's defaulted to 1.
okay.
Okay. For instance, Alva, let me just put here. Okay. Suppose you had the number 6, right?
Yes,
That's equal to 6 over 1. The 1 is the default. I'll put it here. Okay. That's 6 over 1. So let me just put a 1 here. Although most times you don't put the 1 there. Like I say, it's a default.
yes,
So any variable or number without a denominator, the denominator is defaulted to 1. That's why I can say x to the minus 3 over 1.
Okay.
You follow me?
Yes.
yes, Miss Barbara.
Okay, so if you see a variable or number doesn't have a denominator, that default is 1. And you could just put the 1 there if you need to. Most of the
Yes,
times you don't really need it.
you don't
But
have to,
okay,
yeah,
so I just pulled out the x to the minus 3 that went with the 10 and made it x to the minus 3 over 1 to show you the rule that when you have a negative
yes,
exponent, it becomes the reciprocal or the flip of the positive. So for you to really understand it, that's why I put the 1 here. Now this become 1 over x to the third. But I had a 10 up here, so that would just be 10 times 1 over x to the third, which is just 10 over x to the third. And what answer would that be, Alva?
well, I did it and I choose B. I'm not sure I'm right.
No, the 10 doesn't go in the denominator. Mercedes, what did you get from what I just went over? What's the answer?
A is the answer.
Answer is A.
Yes,
Remember, I didn't change my 10.
I did B to Alpha.
yes,
No, the answer is A. The 10 stays where it is.
okay.
This 10 stays where it is, but the power, the
Yes,
x, that's the base, x, and the power is the negative 3. That's what's changing right here. That becomes 1 over x to the third. So if I multiply 10 times 1 over x to the third, I just get 10 over x to the third. Got it?
yes, Miss Barbara.
That's a very important rule now. Just remember, whenever you have a negative exponent, negative power, it becomes a reciprocal. That means you turn it upside down and make your power positive.
Yes, okay.
Two steps. Flip it, change the sign. Got it? Right? Two-step process. We flipped it, 1 over x, and then change the sign from minus to plus. Questions on number 4?
Okay, well, I'm making notes. I don't
Okay,
suppose
Mercedes, you have a question?
I was saying I think I have to do some more of this type to get it in.
Oh, for the you mean the negative? All right.
Plainer.
Okay. Well, let me give you another one here. Okay. Okay. Now, suppose you had let's see. Suppose you had 6, 4, and you had P, and let's make this minus 2. All right. What would that be equal to, Mercedes?
seem to be 32. Um, uh-oh, 32p to the negative plus 2, I should say.
What would you say, Alva? Mercedes says 32p to the second power. What would you say that's equal to?
Um,
I put a plus beside it instead of the takeaway sign.
we are still on 4.
No, Mercedes said she needs some more of these, so I'm putting one up here to practice. I'm giving you 64p to the minus 2 power, and I'm asking you, what is that equal to? Mercedes says 32p to the second. What would you say?
No, maybe we could break it down a little more.
64p to the minus 2.
Yes, but I'm saying, Miss Barbara, if we could break it down a little more.
Okay, what do you want me to break it down to?
Okay, so 32.
Where are you getting a 32?
No, she said 64p minus 2 to the power.
Yeah, but
minus-
she said 32p to the second. Is that what you said, Mercedes?
Yes.
Okay, this is what Mercedes says, 32p, and she said to the second. And I'm asking you, that's what she's saying this is equal to. I'm asking you, what is it equal to?
Okay.
What is 64p to the minus 2 equal to, Alba?
So we'll have to put the 64.
Okay, so I put the 64. What goes after? What goes?
And then you put the 2, the minus 2, under the denominator.
Okay, so this is the numerator. So what do I put in the denominator, Alba?
The minus 2.
Remember, you change the sign when you flip.
Okay, so
So
you're gonna
what goes in
put
the denominator, Alba?
2.
Miss, before you go on,
You
remember
can't,
I
you
said
can't
this
wait a minute, Mercedes. I'm trying to get Alva to tell me what she's saying. So, Alva, what goes in the denominator?
The 2, Miss Barbara.
What about the P? You're throwing away the P?
P minus 2. But you
Changes to what?
change the sign.
So tell me what to write, Alva.
P2.
P to the second.
Yes.
Yeah. P to the second power.
Yeah.
Talk
Sorry.
math to me now. P to the second power. Because 2p is not the same as p to the second, right?
Yes, Miss Barbara, that's true.
Okay. Now, what were you saying, Mercedes?
I was saying the sign beside the P, when you first begin, it says 64p to the, what is it?
64p to the minus 2 power.
Go. So I'm saying I change the sign.
Right. You change the sign, Mercedes, but that would be in the denominator, not the numerator. Plus the 32, you don't do anything to the 64. 64 stays the way it is. Because we didn't say half of 64. We just said 64, right?
Yeah.
So the 64 stays just as it is, Mercedes. The only thing will change is your p to the negative power of 2. It becomes 1 over p to the second.
Okay.
You got it?
Yes.
Yes,
Yes.
ma'am.
So don't make it more complicated than it is now. That coefficient, that's the 64, that stays the same.
Okay.
Leave that right where it is in the numerator, and then just take your p to the minus 2, put that in the denominator, and change your sign.
Okay.
You got it?
Yes, ma'am.
Is it clearer now, Mercedes?
Yes.
Okay.
Yes, Miss Barbara.
So if you have a coefficient, then you just leave that just the way it is.
Okay.
Now, Mercedes, since you want something where you have to change your coefficient, let me give you one where you have to change your coefficient. All right. I want to satisfy your curiosity. Okay. All right. Let's just bring that back. Okay. And I want to give you another problem. Okay. And I'll be going to the next screen. Okay. Now, suppose you had, let me put this here. Okay. 3, and I'll put a power on this to the second power. Right. And now let me put y, and let me put a negative power on here, -4.
Where are you now, Miss Barbara?
I'm on the other side, Alma. Are you moving your screen over? Well,
Oh.
it's on my right. I don't know if yours would be right or left.
Are you on number 5?
No, I'm not on number 5. I'm still doing examples of
Oh,
negative exponents to make sure you understand it. So I'm giving another example. 3 to the second power, y to the -4. Mercedes, what's that equal to? Just give me the answer.
Okay, that so you're gonna keep the 3 to the second power.
What's the answer? What's 3 to the second power?
Okay, the answer is 3 3y to 2 plus 4 in the power.
No. 3 to the second is a coefficient. It's not a
Oh,
multiplication.
that one is a coefficient myself. Okay, 3 to the second power.
It's equal to what,
Y,
Mercedes?
it's equal to 3 to the second power y, and you flip the
No,
sign.
what is 3 to the second? What number is 3 to the second?
That's 9.
9. Very good. It's 9. 3 times 3, right? And what do I put in my denominator?
1.
What goes in the denominator?
Y.
Y. Very good. What power?
4, the 4th power.
That's it. Very good, Mercedes. You got it.
yes. And you take away
You got it. Just put the little y here.
Yes.
That's it. Now you understand, right?
Okay, so
Yeah.
this one what? Multiplication?
No, this is a coefficient 3 to the second in front of the variable y to the -4. So you just 3 to the second is 9. Leave that right there in the numerator. And then y to the -4 goes in the denominator with the sign changed to a +4. You got it?
Okay, got it.
Okay.
Oh, got this one now. I understand this.
Is it making sense now? See, that's just the coefficient. See, I could have just put a number like I did before, like I had 64, I could have put 32, but I put something there that you had to actually simplify it, because see, your answer possibilities would not have 3 to the second. It would have the 3 times 3, and that's 9 that you told me here, okay?
Okay.
And then the y to the -4 would just be 1, just flip it, 1 over y to the +4.
Okay.
Okay, is that clearer now on the negative exponents?
Yes, miss.
Alva, you okay with this?
Yes, Miss Barbara, yes.
Okay, because I was just doing that example there to reinforce you understanding it, right?
Thank you.
Okay, number 5. Let's see if you did that one. Number 5.
Right.
No, you didn't do that one. Well, you did it, but you did it incorrect. And so did you, Alva. Okay, so let's see, how would you simplify this?
The same one you're on?
Number 5, we're on number 5, 7. Let me just copy this.
I didn't do that one because,
What was the problem, Alma?
okay, how I was doing it, I was saying 5 into 20. 5 plus 20, that's 25. I really didn't understand how to do this one. So.
Mercedes, any ideas on this one?
Miss, when I looked at when I look at the 5 and the 20, I know to clear up that, but I can't figure out the 7. I can figure out what to do with the 7.
The 7 is a prime number. You don't do anything with it. Leave it just the way it is. The 5 is the 5 is a prime number. Leave it the way it is. 7 is a prime number. Leave it the way it is. 20 is not a prime number. 20 factors into numbers, one of which has a perfect square root.
Oh,
Mercedes, what are some factors of 20?
10. No, that's sorry, 2.
2 and what?
4, 2 and 10.
Okay, 2 times 10. Okay, Abba, give me 2 other factors of 20. Two numbers you can multiply and get 20.
I would say 4 and 5.
4 and 5. Perfect numbers. Why are those perfect?
Because, okay, I know 4 you can get multiply 2 2s.
That's it. Very good. 4 is a perfect square root. 2 times 2. So you take the square root of 20 and we can factor that into 2 square roots, right?
Yes.
Let me just put that here. Let's take the square root of 20. And that factors into what you just said, Alba, the 4 and the 5. So this factors into square root of 4. Let's put the square root of 4. And times the square root of 5. So this would be square root of 4 times square root of 5. Let's put the 5 here. Okay. Is that clear to everybody what we just did?
Yes.
So, let's see this. Oh, that's the way I should have written it.
That's it. You've got to factor the 20, and the 20 has 2 factors, and one of them is a perfect square root. So you always look for the factors that are perfect square roots.
So, Miss, in this simplifying case, you have to focus on the bigger number, Miss.
Not always. You got to focus on a number that has factors where 1 is a perfect square root.
So in this case, we have to find the right one. Find
Yes.
another with 5.
Yeah. Well, you said 2 and the 10, those are factors, but neither one of them have a perfect square root.
Okay.
I tell you a little hint. When you have something like this, you think about, well, if I could get a square root of 5, I could add my coefficients, right? So what number multiplies by 5 and get 20? 4.
Okay.
See, look at this 5 here. Because if you could get the coefficient was a square root of 5, then you could add them, right?
Okay.
So think about 5 going to 20 4 times. So radical 20 factors into radical 4 and radical 5. Square root of 20 factors into square root of 4 and square root of 5. Remember, your radicals factor just like numbers factor. You just breaking it up into 2 pieces and you try to have one that's a perfect square root. Got it?
Yes, ma'am.
Okay, so let me just copy this again and substitute in our factoring. All right. So we just put that here. And that's going to be equal to, and we leave the square root of 7 times square root of 5 just the way it is. But the square root of 20 now becomes square root of 4 and square root of 5, right?
5. Yes.
Okay. So we put the square root of 4 because that will factor into a 2, right? And then we put our square root of 5 right next to it.
And that's the answer.
No, we haven't finished yet.
Oh,
Square root of 4, let's put that. And next to that, it's factor square root of 5. Okay, there we go. Let's put the 5. All right, now we're not finished yet because the square root of 4 is what, Alva?
2.
2. So let me just copy that and we put our 2 there. You just showed me the square root of 4 is a 2. So let's just copy that and put it. The square root of 4 is a 2. So let's just put the 2 there. All right. Now, I have coefficients of square root of 5, right? That means I can add these coefficients. What do they add to, Mercedes?
Those.
Yeah. What does the coefficients add up to?
Yeah, 16.
How are you getting 16? The coefficients are 7 and 2. That adds to what?
Okay, it's 9, but I look at the 2, 7. Oh, I overlooked the I do both sides. That's what happened.
No, we are trying to simplify this expression. That's why I'm repeating it,
Okay.
right? So coefficient 7 times square root of 5 plus 2 times square root of 5, and that gives you 9 times square root of 5. That's your answer.
Miss, this one is hard, miss.
Answer 9 times square root of 5. Any questions?
Miss one, this one is hard.
Can you come more another time, Miss Bob?
I really have to do more of this one. Because
What's the problem?
I didn't know you have to stretch this one out so much so far.
When it says simplify, you want to get it in a nice, neat fashion. So I'm telling you your first hint up here. Since you have a 5 and a 7, both of those are what? Prime numbers. So you think of, well, if I can make this square root of 20 something times square root of 5, then I could probably simplify it. So 5 goes into 20 how many times?
4.
4. So you got your square root of 4.
Yes.
That's your clue right there. That 5, that square root of 5. So what can I break square root of 20 into? Square root of 4 and square root of 5. See, right here. Square root of 4, nice, neat square root. 4 is a 2. Now, these are coefficients, just like if this was 7x, 2x, I get 9x, right? 7 times square root of 5 plus 2 times square root of 5 gives me 9 times square root of 5. Because you can add coefficients of radicals just like you do of variables. You got it?
I gotta listen to the recording of this one over and over again. I'm puzzled with a 9.
You puzzle with the 9? You don't know how we got it?
The 2 that she used to take from the square root, she added with the 7. That's
Yes, look here. That's right. Absolutely, Alva. See, this, I'll say this is 7 times square root of 5.
Yes.
Plus 2 times square root of 5. They both are coefficients to the same radical.
Oh.
So I can add them. Just like if I had 7x plus 2x. What would that be equal to, Mercedes?
9x.
9x, same thing, except they're radicals.
So you find a coefficient for, no, you find a, what do you call now? For 4, which is 2. And then you add the 7 and 2, you get the 9.
Yeah, well, let's start back up here. When you look at a problem like this, I want you to be able to see the math. You see a 7 and a square root of 5. 7 is a prime number. 5 is a prime number. So this one is as simple as it can get, right? But your clue is, if I have a square root of 5 here, then I must be able to get a square root of 5 out of this square root of 20. So what are your factors of 20? 4 and 5. What are your factors of square root of 20? Square root of 4 and square root of 5, right here. See how you can figure it out?
Yes, I'm looking.
And once you put that there, then say square root of 4 is a 2. Now I've got my square root of 5s with coefficients, and then I can add them.
Oh, see, okay.
All right.
Okay, Miss Barbara.
Is it clearer now?
Yes.
Yeah,
yes.
much. Yeah.
Okay, let me see. Let me take another one. Okay, suppose I said simplify. Take another one and see if you can use what we went over to do it. Okay, now 7 times square root of 5. I want to do, let's see. Let's make this 2 times square root of 3. Okay, plus square root of 48. Okay. Now using the same principle I did for the other one, how could you get the answer for this one? Any ideas, Mercedes, Alva?
You're still on the same one?
No, I'm trying another example so you can apply what we just went through to
Yeah, but
this one.
I'm not seeing that one.
It's on the other side, Alva.
Mm,
2 times square root of 3 plus square root of 48. Mercedes, do you see it?
Okay, 2 times.
Think of 48 factors. Mercedes, what are some factors of 48? Mercedes, you're on mute. Mercedes, you're on mute.
Oh, I thought I took it off. I'm sorry.
Okay,
My phone rang, so I did cut off the call to get back to you.
okay. 48 equals, what are some factors of 48?
2.
Can it be 24?
No. Remember when I told you about the hint? So what would you look at right here to get a hint as to what your factor should be? Your clue here is what? The 3.
3, yes.
Okay, so Alva, 3 times what gives 48?
True.
3 times what number gives 48?
Mm,
3 into 48 goes how many times?
Okay, 3 is 24.
3 into 48.
Yeah.
48 divided by 3 gives what,
6,
Alva?
6, Miss Barbara.
Give what?
No, I said 6 can go into 40.
3 into 48. 48 divided by 3?
3 times
You said 3 into 48.
3 times what number, Alva, gives 48?
Okay, so I will say,
Or 48 divided by 3. Mental math.
I know I'm saying that 3 into 40, it goes 4 times, no?
How many times?
4 times?
3 times 4 is 12.
12 out of 24.
3 into 48. It's got to be a 2-digit number.
Yes, ma'am.
So what is it?
3 times. Okay. I'm not sharp with this one, Miss Barbara.
You have your calculator?
Yes. 3
Use your calculator. 48 divided by 3 equals what?
Okay. 48. Just a minute, Miss Barbara.
48 divided by 3.
Oh, my thing here not working. Let me clear it.
48 divided by 3.
16.
Mercedes, I'm talking to Alva. Thank
Oh,
you.
sorry. I thought you said
Thank
no.
you. Alva,
I'm sorry.
48 divided by 3.
Okay. 48. 48 divided by 3 equals 16.
16.
Yes.
There's got to be a 2-digit number, Alva, because 3 times 10 is 30. So you know it's got to be bigger than 10. That's how
Yeah.
you can figure it out. Then you say 3 times 15 is 45.
Yeah.
So it's got to be bigger than
That's a good
15.
figure.
Okay.
Yes.
Okay. 3 times 16, but 16 is a perfect square root, right?
Yes.
Remember I told you how you look at this, the 3 here, because 2 and 3 are prime numbers. So you think about 3 and what factor gives 48? Mercedes, you see how you can figure it out?
Yes, miss.
You got your answer? Mercedes, you have your answer?
16.
For that,
Yeah, the simplification. You got an answer for me?
I don't know how to write it out.
This would be square root of 16. Put the 16 here.
Okay.
And that would be times the square root of 3, right? So let's just put the square root of 3 there. That factors into
40.
square root of 16 times square root of 3. That's what the square root of 48 factors into, right? There you go. You follow me, Alva?
Yes, Miss Barbara.
The square root of 48 factors into the square root of 16 times
Yeah.
square root of 3. Mercedes, what is that equal to? What's the square root of 16?
Square root of 68.
8 times 8 is 64.
Oh, Lord, 4.
4. Thank you, thank you. I know when you said it, you said, oh, no, no. So square root of 16 is a 4. So then we make that a 4. Now, what's the answer, Mercedes?
Uh-oh.
What is that equal to? Add the coefficients.
What's that's 16?
4 plus 2, Mercedes.
4 plus
Your coefficients are 2 and 4. 2 plus 4 is what, Mercedes?
8.
2 plus 4.
2. Oh, a plus. Sorry, I'm talking about multiplication.
2 plus, I didn't say times.
6.
6. Know your math operations. Listen up. So that'll be 6 times square root of 3. That's your answer.
So
6 times square root of 3. That's the answer. Question?
how you work back to 48?
What was the question, Mercedes?
How it work back to 48? I'm looking at it. So, okay. Let me look at it. 6 times 3. 6 times 8 is 48. And 3 times
No,
6.
no, wait, Mercedes. Go back up here, right? 2 and square root of 3 are prime numbers. So 2 times square root of 3 is already simplified. But you say, well, maybe I can get a square root of 3 out of my 48. Factors of 48 are 16 and 3. So I can get a square root of 16 times square root of 3 as factors of square root of 48. You see how you use what's given here to solve the problem. I'm trying to get a square root of 3 out of my square root of 48. Then I can combine them, right? But 48 does have factors of square root of 16 and square root of 3, square root of 16, perfect square root 4. Now I have the coefficients of the same radical and I could just add them. 4 and 2 are 6. 6 times square root of 3 would be the simplification of this expression. Question?
Because 3 times 16 make 48.
That's right.
And
So that means square root of 3 times square root of 16 equals square root of 48. Got it? Now, ladies, did that answer your question? Make it clearer?
a little bit. And
Okay, so what's the problem? What part of this is not clear to you?
like when you get the answers, you have to know to write it down.
I'm sorry, what is it?
How to write it,
Well, you have coefficient 2 in front of the square root of 3 and coefficient 4. So when you have a coefficient and a radical or coefficient and a variable, you just add the coefficients. Just like I told you, if this was 2x plus 4x, you get 6x. So 2 times square root of 3 plus 4 times square root of 3 is 6 times square root of 3. Got it?
Yes, ma'am.
Mercedes?
Yes, I'm hearing it. Okay.
What did I just say, Mercedes?
I'm trying to see if I feel what you're saying. You're saying the 2 times square root of 3 gave you 6.
No, I'm saying by add the coefficients 2 and 4, I get 6. Because those coefficients are under in front of the same radical, square root of 3.
Okay. Okay. Oh yeah, 3 is at the bottom and 2 at the top, 3 at the bottom and 4 at the top. What?
2, no, this is not top. This is 2 times square root of 3 plus 4 times square root of 3. And I can just add the coefficients 2 and 4 and get 6.
Is in front of 3. Okay.
You got it?
Yeah.
It's not a fraction. It's an expression with the coefficient, and here it's a radical. It could have been a variable. It could be 2a plus 4a, be 6a.
Okay.
Got it?
Yes, I will review what you tell me on the recorded again.
Okay. All right. Well, just remember when you get coefficients in front of the same radical, you could just add the coefficients, just like you do if they were in front of variables.
Okay.
Okay, so you can treat these just like if it was a variable. If this had been a z, 2z plus 4z would be 6z.
Okay.
So 2 times square root of 3 plus 4 times square root of 3 is 6 times square root of 3 because I just add the coefficient 2 and 4. Got it?
Yes.
See, this is the same as saying, let me just put that. This is the same as saying if this was 2 plus 4, and I put that in front of square root of 3. All right. Okay. See, that's the same. And 2 and 4 is 6, right? So that'll be 6 times square root of 3. Add the coefficients. So 6, and this will be square root of 3. Got it?
Okay, miss.
Yeah, those are the codes. Just so remember your terms now. Numbers in front of variables or radicals, those are coefficients. And if they are in front of the same radical or same variable, you can just add them.
Okay.
Got it?
Yeah.
Okay. All right. Now, you remember what I said about rationalizing? What is rationalizing, Mercedes? You remember we were rationalizing the denominator. What does that really mean?
Remember, miss, honestly.
Rationalizing is getting rid of the radical in the denominator. How do we do that? By multiplying it by the radical. In other words, the denominator here has a square root of 2. So you're going to multiply this whole expression by square root of 2 over square root of 2. And that's 1, right? So let's just copy this. Okay, and put it here. So the operation here is we want to get rid of the radical in the denominator. All right. And what's in the denominator, Mercedes? What do you see in the denominator?
I see 3 times 1.
That's numerator. Top
Sorry.
numerator, bottom denominator. What's in the denominator?
Let me want to sleep. 2. That's 2. What do you call it? Radical.
2 times the square root of 2, or radical 2. You could call it radical 2, or you can say square root of 2.
You're on 6, Miss Barbara.
Yes, on number 6.
I don't know if I got that one right. I think I picked D.
Okay, you pick one?
I think I sent you D.
No, it's not D, and we'll show you actually what it is. So I'm going through this in steps. So when you rationalize, all that is making your denominator a rational number. In other words, you're getting rid of the radical in the denominator. How do we do this? By multiplying by the radical over the radical. So we will take this. Okay, just do this. Okay, so this is equal to, and 3 times 1 is 3. And this will be over 2 times square root of 2. So let's just put that there. And then just repeat this. So 3 times 1 is just 3. Okay. Now let's put in the denominator 2 times square root of 2. Now we will multiply this by square root of 2 over square root of 2. So let me just put that. Okay. And let me put the asterisk for multiplication. Now we'll say square root of 2 over square root of 2. And that's just 1, right? So this will be square root of 2. And we pick the square root of 2 because that's what's in the radical.
Yes.
Okay. So this is times square root of 2. And underneath it, square root of 2. And that's just like multiplying by 1. So we multiply by 1, we really don't change the value, right?
Okay.
So that's over square root of 2. So let's just put that there. and put our square root of 2 here. Now, that's your first step. Multiply the numerator by square root of 2 and the denominator by square root of 2. Reason we pick square root of 2 because that's what's in the denominator. Got it?
Okay.
Now, you remember what I say when you multiply a radical by itself, what you get? Mercedes, you remember what I said?
No,
A
miss.
square root of 2 times square root of 2. Alba, you have an idea what that's equal to?
One.
Square root of 2 times the square root of 2. What is that equal to, Alba?
4,
Mhm.
Nope.
1.
Nope.
Okay.
Whenever you multiply a radical by itself, you just get the radicand, the number that's under the radical. That's just a 2.
Oh,
Okay.
Remember now, Mercedes?
yes, miss.
Because when you say radical square root of 2, you're really saying 2 to the 1/2 power. And 1/2 plus 1/2 is 2 to the 1. So this is true for any radical. When you multiply by itself, you get just the radicand. So square root of 10 times square root of 10 is just 10.
All right.
Square root of 100 times square root of 100 is 100. So square root of 2 times square root of 2 is 2,
Two.
right?
Okay.
So let's go back up here. All right. Okay, and I'll put my equal sign. Now, the top, I'll just have 3 times the square root of 2, right? All right. Now, the bottom, what would I have, Mercedes? The denominator. 2 times square root of 2 times square root of 2. What would that be equal to, Mercedes?
2.
No, 2 times square root of 2 times. That's
2 times square root of 2 times square root of 2. Mercedes, what's that equal to?
8.
No, what would you say, Alva?
3 times square root. I would say 6.
No, 2 times
2
square root of
times
2 times square root of 2. Well, let me just put it
4
here.
multiplied by
2
and 2,
square
16.
root of 2. No, let me just put it here. Square root of 2 and put that there again. Okay, now what is that denominator equal to?
2.
Mercedes, you got the answer?
That 2.
What is it?
2.
No.
Radical 2.
Okay,
Didn't
now,
I say 8, Miss Barbara?
it's not, you said 8, but it's not 8.
Oh, it's not you.
The radical 2, if you call it
Sorry. Okay. Okay. Square root of 3 times and square root of 2, this was, okay. Let me just put that there again so you'll have it. Okay. What I'm asking you, what is 2 times square root of 2 times square root of 2? What is that equal to?
2 times square root.
Mercedes, you got it?
Is it 1, miss?
No. Okay. 3 times square root of 2. Let's just put that. That stays the same. That's in the numerator. Let's put that there. Okay. Okay. Now, square root of 2 times square root of 2 is what, Mercedes?
Square root of 2.
What did I just say about the square root of the same number by itself? It's just what? 2, right? So you had a 2 in front of that, right? Now the square root of 2 times square root of 2 is just 2. So what's 2 times 2?
4.
4. There's your answer. Okay, that's equal 3 times square root of 2, let's just copy that. 3 times square root of 2 over 4,
Oh,
right?
it sound like you were saying 3 twos. That's why I keep on saying.
No,
That's why
that's why I wrote it here, Mercedes. 2 times square root of 2 times square root of 2. Right here. You see it.
and I do it like I say like 2 twos, 4, 4 twos, 8. The rest eight.
No, but remember when I say the radical by itself is just the radicand. It's just a 2.
Yeah.
So that's a
Oh,
4.
that's how we write it. Oh.
Yeah.
And then you do it and put the answer on there.
Yeah. And what answer is that?
That
What
is number
what answer, Mercedes?
answer B.
B. That's
Wait.
right. Answer B.
Oh, I got D. I don't.
But what number is that?
3 times square root of 2 over 4. You said answer B. Is that what you just said?
I don't know. I'm just asking what math readers did a while ago. Number 6 readers.
Number 6. So that's answer B.
And if that's what I have, B for the answer. I just guessed that anyway.
Okay, answer B. All right. So
I
let's,
just look at it, miss, and look at it and guess that the answer is B. I
okay.
didn't look at it the way you did.
But you should know the process of doing it though. All right. When you rationalize the denominator, you multiply in both numerator and denominator by the radical. So the denominator has square root of 2. You multiply both the numerator and the denominator by that radical 2.
Okay.
Okay, 3 times radical 2, 2 times radical 2 times radical 2. So that's how you got the 4, because radical 2 times radical 2 is 2, and 2 times 2 is 4.
Okay.
Questions?
No, miss, thank you.
Okay. Alva,
Yes, Miss Barbara.
what did I just say?
You said 2 times radical 2.
No, give me a general. What did I say about when you rationalize the denominator? What do? You
You
multiply
multiply
numerator and denominator by what?
by itself.
By the radical.
Okay.
In other words, this denominator has the radical 2, right? Square root of 2 right here.
Yes.
That's what you're going to multiply the numerator and the denominator. That's why we have square root of 2 over the square root of 2 multiplied by this whole expression. Numerator multiplied by square root of 2, denominator multiplied by square root of 2. So that's your first step in rationalizing your denominator. Multiply your numerator and your denominator by the square root that's in the denominator. Like if this had been a square root of 3, then we multiply both numerator and denominator by square root of 3. Got it?
Yes, ma'am.
Mercedes, you okay with that?
Yes, miss.
Okay. But remember I said, what did I say about when you multiply a radical by itself? What do you get, Mercedes?
The radicand.
Get the radicand, just a number other the radical. So square root of 2 times square root of 2 is 2. Square root of 8 times square root of 8 is 8. All right.
Okay.
Square root of minus 4 times square root of minus 4 is just minus 4. You know, if you had negative numbers, generally we don't deal with negative square roots. But if you did, it would just be negative 4. Number 7. Let's see. Did you get that one right? 7.
I got I think I sent the number 7.
You had that one right, Mercedes. You said B. That was correct.
Okay.
Okay. All right.
I
Now, what did you have, Alva?
I put 100,000.
10 to the 6. That means your decimal point is moved 6 places to the left.
To the left.
So which answer here do you move the decimal point 6 places to the left?
Here on the book. I have it on the
Which one
phone.
would it be? Well, which one would it be, Alba?
Oh, can you bring it up for me? I cannot pick it up on the phone like that.
Okay. Can you see it now? Number 7. It's on the other side.
Yes.
Okay. Now, which one of these numbers you move the decimal point 6
Okay.
places to the left and get 10 to the 6?
Let me see. 6 places to the left.
Yes.
Okay.
Because if your
Oh.
exponent is
I
positive,
wasn't reading it right, Miss Barbara. That's what happened. That's why I picked it. Well, if I move 6 places to the left, I would get 1, 2, 3, 6 to the left. So I would get like
which answer? A, B, C, or D? You get
it would
1
be
times
it
10 to
would
the
be
6.
it
Which
would be
which
B.
one? It would be
B.
B. That's right. Answer B.
Yes,
Because your decimal point is right here after this last 0, right?
yes, I made a
And 6
mistake.
places would be 1, 2, 3, 4, 5, 6. And it would be right here. 1
Yes,
times 10 to the 6. So the
yes,
answer would be B.
B. I
Got it?
read it. I read it wrong.
Yeah, if our group raised 10 to the $6, how much money did we raise? So you look at all these choices, and the
Yes,
only one that you can move 6 places to the left and get 1 times 10 to the 6 is this one, 3, 6. You can just count the zeros. 6 zeros put you at the 1 after the 1.
left.
1
Yeah.
times 10 to the 6. All right. Let's see, Mercedes, you had that one right. Okay.
Okay.
Now, number 8, let's see what did you do on number 8.
I was working
I
on
don't,
this one, but I didn't get it. I didn't
yeah,
send it.
Mercedes, you gave me 2.10. I don't know where you got that from.
Oh boy.
Did I give you 2 point?
You said 2.10. That's a 2223.
What?
Yeah, you said 2. You
But
gave me an answer 2.10 to the 9th power.
I thought I give you 2.2 times 10 to the 9th power.
No, you gave me 2.10 to the 9th power.
An error, miss. It's 2. It's 2. I have written the paper looking at it right. I have 2.2 times 10 to the 9th power. That's what I
Yeah,
have.
well, what you gave me that I looked at on your message was 2.10.
I made mistake.
Okay, so Alva, what's the answer for number 8? Now your decimal point is after this last 0. Now you're moving it to the left where it's between what 2 digits, Alva? This would be what? 2 what?
You're moving the first digit here to the left.
You're
And
moving
it's
it. Yes. So what would it become then? And remember, it has to be less than 10. So where would your decimal point be? Between what 2 digits? You're
okay.
moving it. It's going to be between the first 2s, right? So this
Yeah.
becomes 2.223. Now you got that. Then times the 10. And how many places did you move it, Alba? Just count the digits to here. How many is that?
1, 2, 3.
Just count all these digits up to here.
1, 2,
How many is that?
3, 4, 5, 6, 7, 8, 9.
That's it. Very good. So that would be a 9.
Miss, a question there.
Yes.
So I should have bring forward the 2 after I put 2 point. I didn't understand. Although I have it on my paper, what I have on my paper is 2 point. Hold on, 2.2 times 10 to the 9th power. But I didn't realize I should bring it. I should write 2.223.
That's right. Because that's what's on the number. I didn't say
Okay.
round it.
I
Did I
didn't
say
know.
rounded?
No,
no,
you didn't say.
If I didn't say
right.
rounded, you just put it between the first two twos, then that becomes, it's right here, 2.223 times 10, and you moved it over 9 places, 6 zeros, and then 223 make 9. Got it?
Okay.
Natasha, you put those two.
Yeah. No, we've been using exact digits because we haven't rounded yet. You got it?
Okay.
Okay, now
The
let's see.
last one is 9.
The other one you didn't, well, let's see, Mercedes, what did you give me? You said 5.10 to the 8th power. I don't know what.
Miss
Mercedes,
Barbara, where it didn't come on my phone yet.
You
okay,
know what, miss? That one I
yes,
guess because I didn't understand to set that one. I didn't know how to write that one.
okay.
I
Now
just
this is moved to the right, so you know it's going to be a negative exponent, right? So Alva, where would you move? The decimal point is here. Where would you move it? Between what 2 digits?
Where are you, Miss Barbara? I'm not
Number
seeing.
8, the second part of number 8.
Oh, number 8.
We're converting from normal notation to scientific notation.
I'm not seeing.
That's
Oh,
the
number.
number times 10 to a power. So the
Mm,
decimal point is right here.
I'm not seeing it. This is the one that we just finished.
You don't see the one right behind it. It's right below it.
No,
You don't see 7505?
no, it's not coming up on my phone.
But you had this one, it's right behind it. It's right below it. Although you don't see 7505 with 5 zeros in front of it.
7505.
Yes.
Oh, yes, Miss Barbara. Yes.
Okay. Now, where would you move the decimal point, Alva? It's right here. Where would you move it? Between what 2 digits?
It's gonna move to the left. No.
No, we're moving to the right, but
Oh,
between
okay.
what 2 digits? See, for the really big numbers, we moved here to the left. For the small numbers, numbers less than 1, we move to the right. Now, where would the decimal point go, Alva? Between what 2 digits?
Okay.
I'll start you off 7. Between 7 and what?
Would it be 775?
Got to be less than 10. So it's got to be less than 10. So where would the decimal point go?
Between the zeros? No.
No,
But are we going to the left or?
no, you're going to the right. Your decimal point is here. You're going this way.
Yeah, but what digit are you looking for?
No, I'm asking you, where would I put the decimal point? Between what 2 digits?
I would say, how much is this number? First of all, is it 7,500 or 7,505?
No, where would I put the decimal for scientific notation?
You'd have to put it at this 0, the one beside the 7.
No, I put the 7 there,
Mhm.
but where would the decimal point go? Would it be 75 or be 7.5, be 750? To be less than 10, it has to be 7.505.
Okay, 7.505.
That's a number less than 10, because if you moved it someplace else, your number is going to be greater than 10.
You'd have to put it at the 7.
You'd put it after the 7, 7.505, decimal
Yeah.
point here, and I
Yeah.
moved it here,
Right.
right, between the 7 and the 5. Always time the base 10. How many places did I move it, Alba?
You move it one place. You move it, just a minute, Miss Lover. 1, 2, 3, 4, 5, 6 places.
6 places. Now, since I moved it to the right, it would be a negative. So what
Yes.
would what would it be then? What
Okay.
would be the power? You said a 6, that was right. It would be a negative. So what would I put here?
For the power,
Yes.
we have to put a minus 9,
No, you just told me a 6.
minus 6, yeah,
Minus 6. That's it.
because it's negative. Yeah.
Yes, because when you move
And
to the right, it's negative. So
it's-
you moved it 6 places to the right,
and it's
negative exponent. So 7.505 times 10 to the minus 6.
yes, and I remember that stick in the head. If you move
Okay.
to the left, it's negative. It's
No,
positive.
it's positive. And if you move to the right, it's negative. Or the
Negative.
way to remember it, if the number is a number less than 1, you're going to always have a negative exponent. See,
Right.
these numbers like this are less than 1. If it's greater than 1, you're going to have a positive. Okay.
And if you move to
So,
the
Miss,
right, it's negative.
Well, 1 or greater, but less than 1, that's a decimal number. And it's going to always be negative for your decimal numbers. Less than 1. Yes, Mercedes.
so because 7 is less than 10, that's why we stop there.
Yeah, but it's 7.5 because if you went this, if you moved it between 5 and 0, it'd be 75, Mercedes. That's
But
greater than 10.
okay, because I understood the left and right position, but when I get there, I was sort of, I don't sure.
Yeah, but when you say less than 10, that means you can't have 75, you can't have 750, you can't have 7,505. Less than 10 is the 7.5. Just like up here, less than 10, not 22.23, but 2.223. Got
Okay.
it?
Yes, thank you.
That's what we mean, less than
I'm
10.
not surprised that I got it wrong because I was wondering, does the side go 10 just like the other side with the 2 with 10? I didn't remember that. I understand left and right position.
Yeah, but just remember the first step is getting the number after you move the decimal point. That number must be less than 10.
Okay.
All right.
That's nice.
Now, in some cases, it may not. If you're trying to get a problem, work a problem out, you may want to make it greater than that, but that's a different kind of problem. But for what we're doing here for conversion, it should be a number less than 10 times the base 10 raised to a power positive when you move to the left, power negative when you move to the right. Got it?
Yes, ma'am.
Now,
we have one more leave on this number 9.
number 9, we went from scientific notation to normal. Okay.
So how much?
Yeah, we want to go from 6.05 times 10 to the 5th, and we want to write it as the normal number. What would this look like, Alba?
I was trying to figure it out, and
Now that means we had 605. We can just write that out. We know we got 605. Now, how many zeros would I have to have here, Alba, that I can move it to the left and get the 5th power? So how many zeros?
6.5.
How many zeros will follow the 605 to get 10 to the 5th?
Would you move it 4 places?
No, how many zeros would go after? See, I've got 6.05, so I know I had 605, but how many zeros would follow this so that when I move it to the left, I get 6.05 times 10 to the 5th. So how many zeros would follow the 5?
Okay.
Tell me how many zeros to write.
would it be 6 zeros?
No. See, I already have 2 right here, right? Because I got
And you need,
6.05. Then I
oh,
just need how many more zeros to make 5?
okay, you need, you already have how many, Miss
I
Barbara?
already have 2 places right here to get the 6.0.
Okay,
So how many zeros do I need to add to get 5?
you need to add, you need to add 4 more.
No, I need 3 more,
Yeah, because you have 0,
right?
5.
Because it's, yes, see, I have 10 to the 5th, but see, 605, I have, and when I put a decimal point right here, I have 05. And to get
Yeah.
5, I only need 3 more zeros. 1, 2, 3. Because when I move from here to here, that would give me a 6.05
So,
times
so
10
you're
to the
moving,
5th.
are you moving it to the left?
I'm moving it to the left because to get the 6.05, my decimal point is right here after that last 0. Then if I
Yeah.
move it between the 6 and the 0, that becomes 605. How many places did I move it? 1, 2, 3, 4, 5. Got it? So that's really 605,000. I could put a comma here. That doesn't change anything. Okay. So it's 605,000.
Okay, so you would have to put 3 more zeros
Right. I
in
put 3
front
more
of the
zeros
6.
because I already have 2 places right here for my
Yeah.
6.05. So to get this to the 5th power, I need to add 3 more zeros. Then that gives me 5 places, right? 1, 2, 3, 4, 5. Got it?
I'm not seeing how you're doing it, Miss Barbara. Let me fix that. Let me bring it up.
Mercedes, you see how we got 605,000?
Yes, miss, yes.
Okay, we have,
I didn't understand where to put the point.
Yeah. Well, just write, when you have this, just write the 605, right? Because it's
Yes.
6105. So just write the 605. Now you've got 2 places right here. So if it's going to the 5th power,
just
you
put
just need
3
3
more.
more. So just put 3
Oh,
zeros. And then when you move it, 1, 2, 3, 4, 5, you've got the 6.05 times 10 to the 5th.
so that you would write as 605,000?
Yes.
Okay.
As the normal number is 605,000.
Okay.
Question?
No, miss.
Mercedes, you okay on that? Yes, Alba.
Okay.
I need a little more practice on the scientific and the
Yeah,
notation.
we'll look at a couple of more because I want you to really, because Alba, you weren't here when we went over it. So when we finish this one, I think what we have number 9. I think we have, let's see. We have number 10 and 11.
So don't
All right.
the 1.4.
Okay, let's do this one. Now this is 1.4 times 10 to the second. So we know this is a decimal, right? 0.14, right? Now
Okay.
this is times 10 to the minus 2. That means we move how many places? 2 places, right? So this would be 0, 1, 4. Because if you move it 2 places, you get it's 1 and between the 1 and the 4. So that's like 10, 100,000, 14,000. Got it?
This one catch me.
If you move it, okay, Miss
Well,
Barbara.
yeah, because see, this is 1.4 times 10 to the minus 2. So that means you're moving your decimal point to the right between the 1 and the 4. So you put the 1 and the 4 there, right? And then you just put a 0 in front of it. That would give you the 2 places. 1, 2.
Okay.
You got it, Mercedes?
But this one catch me, Mr. I did the other way around.
Yeah, you just put the 1, 4, right? Once
Yeah.
you put the 1, 4 there, you says, well, I got to move it 2 places to the right. That means I need a 0 in front of it.
Okay.
And then
Okay.
that's 1, 2. between the 1 and the 4. So 1.4, 2 places, 10 to the minus 2 because you moved it to the right. And it's a less than 1.
Mm.
Got it?
That's so good, but it's sticking out.
That's me.
Okay. Wait, before we go to the next, let's see. Albert, if I gave you this number, okay, 208,000, and I say, write this in scientific notation. Give me the number less than 10 first. Where would you move the decimal point? Decimal point is right here, and you'll move it between what 2 digits?
This is 208,000.
Right, and I want to write it in scientific notation. Now, what would be the number in front of my base 10? So the number, I'm right here, and I want to move it. Tell me where to move it, between what 2 digits?
You'd have to move it between the 0 and the 8.
No, that would be 20. If I put it here, it's 20. That's greater than 10. Remember, it's got to be less than 10. So pick another 2 digits.
Okay, so you'd have to move it between the 2.
The 2 and the 0. That's right.
Yeah.
2. So this would be 2.08.
0.
So now you got the right, number.
Yes.
Between the 2 and the 0.
And
That would
zero.
be give you a number less than 10. Now you put times 10, and how many places did you move it?
You move it 2 places.
No, you're right
Mm.
here.
Oh,
After the
okay.
last 0. So just count the digits. 1, 2, 3, 4, 5.
5.
That would be 10 to the 5th, right?
Yes.
That's it.
Okay.
So first step, pick the number less than 10. That was 2.08.
Yes.
Always time the base 10. How many place you moved it? Just count the digits. 1, 2, 3, 4, 5.
Okay.
You got it?
Yes, ma'am.
Okay, Albert, since you said you got it, let's see, let's try another one. Suppose you had 5, 6, 7, 8. What would that be equal to?
560.
That's 5,678. Now,
Yeah.
what number less than 10 do I write first?
Less than 10.
Where would the decimal point go? Between what digits?
Let me see, units by the 7.
No, that'll be 5, 6, or 7. Remember your number, your first number's got to be less than 10.
Okay, so it would have to be between the 6 and the 7.
That would be 56. That's greater than 10.
Oh, 56. So it would have to go between the 5 and the 6.
That's it, Albert. Very
Yes,
good.
yes.
Between the 5 and the 6 is less than 10. So that would be 5.678 times 10. How many places did you move it?
You move it 1, 2, 3.
Very good, Albert. 3
Yeah.
places. That's it. That's it.
You're
And
talking
10.
about money here.
10 to the 3rd is 1,000. 1,000 times 5.678 is 5,678. Got it?
Yes. Yes, ma'am.
I think you're getting it. Let's just do one more decimal, Albert. Mercedes, you okay, right?
Yeah, I'm listening.
Okay. Now, do this one, Albert. 0, 0, 3. Okay. What is that equal to, Albert? Where would your decimal point go? It's right here. You'll move it between what 2 digits? It's right there. Tell me where to move it.
Okay. If you're writing,
Between what two digits will my decimal point go after I shift it? It's right here, and I'm moving it where?
you're moving it to the right.
That's right. Between what two digits?
You're gonna move it between the 3 and the 0. That's I don't
No,
really know
no.
what you're writing.
Between the 3 and the 5, right? Because that would be less than 10, right?
Yes.
3.54
Yes, that's less than
times 10. What's your decimal, Mercedes? What's your power?
The power is 1 minute. 1, 2, 3, 4, 6.
How many
I-
places did I move it?
3 places, miss.
No,
No, 2 places.
no,
Sorry, 6 places.
no.
What? Let me count it again.
1, 2, 3, 4 places. Negative or positive, Mercedes?
Positive.
No, to the right is negative.
Lordy.
-4.
What happened to me now, miss? Because I have to wait up for a call today when I come from work. I didn't get to sleep yet.
Okay, 1, 2,
That's not
3,
right.
4. It's less than 1, so it's a negative exponent. You move the 4, just count. 1, 2, 3, 4. Okay.
So,
All righty.
Miss Barbara, my phone is gonna run down.
Okay.
I got streak already in it.
I think that's
I'm
it,
glad.
right? I think I had some. Let's see.
you have to charge while you're using it.
Yeah, but where I'm sitting, I don't have any. I have a charger there, but I don't have the plug to plug it in.
You have to keep an extension near you.
No, I do have an
Okay,
extension.
so let's see. We'll stop here, and then I want to look at. Let me do a new share. Okay, new share. I wanted to look at just a little bit at probabilities. We'll really get into probabilities.
Our phone gonna black out, miss.
Hmm?
Our phone is gonna black out.
Okay.
You
All
want to
right.
be
Well, I just want to do a little introduction to probabilities. Do you see the screen?
yes,
Yes, I'm seeing it. Miss Barbara.
Probabilities. Okay.
miss.
Probabilities is how something is likely to happen. Like you say, what's the probability? What would you say the probability of you being struck by lightning? Mercedes.
Uh, 1, 2, 2.
What would you
It
say?
can it can happen. It cannot happen. If it's
Oh,
a
so you're saying it's 0.
it's a possibility.
I
If
will.
something cannot happen, it's a 0.
Okay,
You say I cannot be struck by lightning, your probability is 0.
but we can't say that, Miss
I
Barbara.
can't say that.
So what would you? Now probability can be given as ratios, it can be given as percents, it can be given as fractions.
Yeah,
Okay, it's saying how likely how likely would it be for you to hit the New York?
Lotto.
Yeah, what's
Well,
the
that
Powerball?
that
Alma,
is.
how likely would it be for you to hit the Powerball?
I would say 100 to 1.
It's even more than that. It's in the millions. It's
If
like you're one in so many million chances because it's just so many possibilities, so many combinations
Yeah.
of numbers. Just think of all the combinations of 6 numbers with a what 5 numbers and then an extra number. So it's in the millions, right?
Yes.
okay.
I mean, it's not 0 because
You would,
people do win those contests,
yeah.
right?
So
But
would you say 1,000,000 to 1?
no, it's more than that. It's more than that. It's probably in the hundreds of millions. But now to really understand probability, what one of the best examples is flipping a coin.
Okay.
Now, what are the possible ways when you flip a coin? What are the possible things that can happen, Alva?
It's a either head or tail. So
You get heads or tails, right?
yes.
There's
Yes.
nothing else you could get.
No.
So we call that your outcomes. You can
Okay.
only get,
The outcome.
we call that the number of outcomes. It's only two, heads or tails, right?
Yes.
Now,
Yes.
is it a way they can happen together?
No.
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 It's either one or the
Yeah,
other.
so the
Yeah.
possible outcomes are just heads or tails. So what would be the percent, if you had to put this as a percent, Mercedes, what would be the percent probability of you getting a head when you flip a coin?
1.
What
1.
percent?
Yes.
What would be your percent chance of getting a head or a tail?
1%. 1%.
What?
I'd say 50%.
50%.
Yeah.
Because it's 1/2.
Yes.
You have the heads or tails, and you have the total is 2. That's total number of outcomes is a head and a tail. So it's
Okay.
1/2. You can say 1/2. You can say 50%. You can say ratio 1 to 2, right?
Okay.
Okay. But now if you flip 2 coins, let me just, all right, let me just put this here. Okay. Now let's change it where you have 2 coins. Okay, so you have 2 coins. So if you flip in 2 coins, what combinations could you get, Alva?
2 times.
You flip in 2 coins. You flip 1 coin, then you flip another coin. You flip 1 coin, you flip another coin. What are the possibilities of those 2 coins? What could you get?
The possibility would be 4.
No, I mean, I want to write the combinations, right? So let's just say coin 1 and coin
2.
2.
Yeah.
All right.
Possibility.
Okay, so coin 1, you could have what? Head or, well, you only have 2 possibilities, head or tail. So coin 1, you could have what?
Heads or tail.
So
Head.
which one? You can't have but one at a time.
Oh, 1. Okay.
So what you want to say, a head or a tail?
I would say a head.
Okay, so you say a head. Now, what about coin 2? What do you think? What do you want to say for that one?
Tail.
Okay, you want to say a tail. All right. Now we are to flip again. So what do you want to say for coin 1?
Head. I mean tail.
Oh,
Yeah,
you
it
want
could
to
be
you
tail.
want to say head or tail?
Let it head stay.
Okay. What about coin 2?
Tail.
But you already said that one. I want a different combination.
But I don't understand, Miss Barbara.
No, you said a head and a tail.
Yes.
And you're flipping it again. You say a head on coin 1. What's another combination? What's another possibility on coin 2? You could get a head, right?
Yes. Yes.
Okay. Now, coin 1 again, you could get what? A tail,
Yeah.
and then you could get a head.
So you're flipping 4 coins?
No, I'm flipping only 2, coin 1 and coin 2. Coin 1, I got a head, and coin 2, I got a tail. I could also have coin 1 a head and a coin 2 a head. I could have coin 1 a tail and coin 2 a head. What else could I have? I could have coin 1 a tail and coin 2 a tail.
Yes.
Right? Any other possibilities I could get on 2 coins?
Yes, you could get either head or tail.
You get what?
Heads or tail.
No, I have heads and tails. I have coin 1 a head, coin 2 a tail, coin 1 a head, coin 2 a head, coin 1 a tail, coin 2 a head, coin 1 a tail, coin 2 a tail. Now, looking at these, what would you, Mercedes, what would you say the probability? And we write it like this. Probability
Mhm.
of, let me just put probability of 2 tails. What's the probability of 2 tails on flipping the coin?
You could get
Okay.
2
One,
head
two, three.
also.
What?
One,
Is it
two,
4 coins or 2 coins?
What is it?
Is it 4 coins or 2 coins?
No, it's only 2. You see,
Okay.
2 coins right here. And I say
Yeah.
coin 1, coin 2. You could get a head on coin 1, a tail on coin 2. You could get a head on coin 1 and a head on coin 2. You could get a tail on coin 1 and a head on coin 2. Or you could get a tail on coin 1 and a tail on coin 2.
So the probability is 4 to
So
2.
what's the probability of getting 2 tails with 2 coins?
I would say it's 2 to 8.
1, 1.
No,
Oh,
because it's
1 to
4.
1.
It'll be what?
1 to 1. 1 head,
No.
1 tail.
No,
Okay.
I would need to check up all of it, Miss
Okay.
Barbara.
So
Oh.
see, I did 4 flips. 1,
Oh. I
but the
understand what you mean
flips,
now.
you see, I flipped a coin 1, then a coin 2. Second flip, a coin 1 and a coin 2. Third flip, a coin 1 and a coin 2. Fourth flip, a coin 1 and a coin 2. So the probability of getting 2 tails, how many times did I get 2 tails?
You get
Both side?
2 tails.
2 tails. It would be 8 to 2.
No.
I don't understand.
4 flips, tail, tail, 1. So 1 over 4.
Oh, okay.
All right,
Okay.
because those
Yeah.
are my combinations: head,
Yeah.
tail, head, head, tail, tail. So
So,
1 out of 4 chances with flipping 2 coins, I could get a tail, tail.
all right. Okay.
All right. So the ways it could happen is just one way I can get tail, tail. The number of outcomes is all 4 of these.
Okay.
You got it?
Okay.
So
Miss-
that's what I did with the 2 coins. Now, so the next homework really won't deal with probability because we got to get more into that. But we'll do some more of what we went over before with the simplifying, rationalization,
Yes.
the scientific notation. Okay, so that would be your homework for Thursday. Now remember, next Monday is a holiday. So
Yeah.
I'll be giving you a little extra homework for Thursday to have for the next Thursday. All right, because Monday would be the July 4th.
Okay.
Next Monday.
Yeah.
Yeah.
Any questions on anything we went over?
Well, you cover a lot of
Okay, now
yeah.
practice that scientific notation, practice writing the number, counting the number of places you move the decimal, whether it's
Yeah.
positive or negative. Remember, if it's a number less than 1, your decimal point is negative. Number 1 or greater, positive exponent. Got it?
Okay. Okay, Miss
Okay,
Barbara.
so I say thanks for joining and so long, everybody.
Thank you very
Yes.
much for your service, Miss. Thank you. Appreciate it.
Okay, so,
Have some good days until
all right.
Thursday. Yeah. All
All
right.
right, so bye-bye.
Thank you so much,
I'm
Miss.
gonna
Bye-bye.
charge my phone.
Okay.